Alright, welcome to this video. In this video, we're going to create this fight animation together using Mixamo, Blender, and Rig-GNS. Currently, I have our first character here. This is an original DAZ character that I brought into Blender and rigged using the Rig-Matic tab. I simply followed the rigging steps using these buttons here. After rigging the character, I also created some additional bones for the clothes and hair simulation. Let's quickly see how that works. I'll enter pose mode, select the torso control here, and move it around. As you can see, we already have physics working on the skirt, the top, and the hair. This was done using the SimuQuick tab. That's how we've reached this point. Now, before we begin animating the fight, let's bring in our second character. First, I'll return to object mode. Then we'll come up to File and select Link. Here's the Blender file containing our second character. Let's double-click to open it. We'll open the collection folder, and here we have a collection simply named Collection. This collection contains all the other collections belonging to the character. Click Link, and give Blender a few seconds to load everything. Okay, we can see that something has changed in the scene, which means the character has been linked successfully. I'll press G, followed by X, to move it along the X-axis. And there we have our second character. Let's move it over to the other side of our first character. So here is our linked character. However, we cannot pose it yet. When I press Tab, you can see that pose mode isn't available. Even when I try to select the rig, it won't let me because it's currently treating everything in the collection as a single library object. If we look inside the outliner, we can see the newly linked collections here. The first thing we need to do is move this collection outside the parent collection so that it sits directly under the main scene collection. Now, let's collapse this collection. We currently have one collection for our original character and another collection for the character we just linked. With the linked collection selected, let's right-click it, go to Library Override, choose Make, and then select Contents. Okay, we can see a lot of strange objects around the character. That's coming from the simulation data. Once we play the animation, the coat returns to its normal shape. Simply return to frame 1, and now everything should look better. I'll select the rig again and press G, X, followed by -1 to move it along the X-axis. The deformation we're seeing on the coat is also being caused by the simulation. Once we play the animation or return to frame 1, the coat returns to its normal shape. To make things easier while we're working, let's expand the characters collection in the outliner. Here we can see the simulation collection. We can hide it by clicking this eye icon. That gives us a cleaner scene to work with. Now, let's test the simulation on this linked character as well. I'll select the rig and enter pose mode. Then, I'll select the torso control and move it around. As you can see, this character also has simulation working on the hair and coat. Both of our characters are now inside the scene, fully posable, and ready for us to begin creating the fight animation. So the next thing we'll do is bring in the animations. Let's go to the Animate tab here. With that expanded, I'll open the Import section and click Get, then click Get Mixamo to open the Mixamo website. Alright, now that Mixamo is open, I'll search for Fight A. Okay, it's actually called Fists Fight A. This is the first animation we'll use, and we'll combine it with this other animation because both animations are designed to work together. They're basically two sides of the same fight. I'll select Fists Fight A, come over to Download, change the skin option to Without Skin, the usual settings, and then click Download. Okay, that is downloaded. Next, I'll select Fists Fight B and follow the same process and download it as well. Alright, now we have both animations. Now, back in Blender, I'll expand the action list in the Actions tab. You can see I already have some animations that I previously used to test the characters. Before importing the fight animations, I'll completely remove those test animations from the scene. I'll come over to the outliner and change this from View Layer to Blender File. Then, under Actions, we can see all the actions currently inside the scene. I'll select all of these actions, right-click, and delete them. Alright, now let's change the outliner back to View Layer. Now, in the Import tab, I'll select Import Motion, choose FBX Motion, and then go to my Download folder. Here we have Fists Fight A and Fists Fight B. Let's bring in Fists Fight A first. I'll select the rig and click bind. Now, we can see that the animation has been applied to this character. However, I don't actually want this animation on this girl. I want it on the other character. To change that, I'll click unbind, select the other character's rig, and then click bind again. Okay, we already know what this animation looks like, so I'll go ahead and click bake. We'll bake the whole animation and then click OK. Next, we'll bring in the second animation, which is Fists Fight B. Make sure the other character's rig is selected, and then click bind. Let's play the animation so we can see what this one looks like. Now with this rig selected, I will go ahead and click the bake button, and then click OK. Alright, both animations are now baked onto our characters. The next thing we need to do is make the characters face each other. Someone previously asked me why I don't simply rotate the entire rig on the Z-axis. For example, with the rig selected, I could press R, lock the rotation to the Z-axis, type 90, and rotate the character this way. The reason I don't normally do this is that we're rotating the rig itself, rather than rotating the animation. Let's see why that can become a problem. If I switch to top view, for instance, and decide to use the position button to place the character, you can see that when I move the mouse upward, the character moves sideways instead. The character's movement no longer corresponds with the direction of the mouse. For that reason, I prefer not to rotate the rig itself. Instead, we'll use the rotate button here, which rotates the animation. Let's quickly undo the rotation we just made. Okay, now that the rig is back to its original rotation, I'll click the rotate button. We can now rotate the animation directly. At the top of the screen, we can also see the current rotation value. I'll type 90 and press enter. Alright, now let's return to the top view and use the position button again. This time, when I move the mouse in a particular direction, the character follows the movement of the mouse correctly. That is why I prefer using this rotate button instead of rotating the entire rig. Let's do the same thing for the other character. I'll select its rig, click rotate, type -90, and press enter. Alright, let's play the animation and see what we have. We can now see that the two animations are meant to work together. The characters are facing each other, but we still need to space them correctly using the position button. Before we do that, however, we need to fix the simulation problem with the coat. When we return to frame 1, the animation immediately places the character into this pose. The coat doesn't have enough time to settle around the legs before the movement begins. To fix this, we'll use the NLA editor. I'll switch this timeline area to the non-linear animation editor. Let's increase its size so we can see the animation strips more clearly. Here, we can see the two actions belonging to both characters. If you can only see the animation for the currently selected character, you probably have the Only Show Selected option enabled. With this option enabled, the NLA editor only displays the animation belonging to the object we currently have selected. When I select the other character, you can see that its animation appears instead. I'll disable that option so we can see the animations for both characters at the same time. Now, one way to fix the coat simulation would be to blend the opening pose from their default poses so the coat has enough time to settle before the fight begins. So, I'll push this action down as an NLA strip. Let's confirm which animation belongs to which character. When I move this strip, we can see that it belongs to the character in skirt. This other strip belongs to the character wearing the coat. Now that we know which is which, I will select this top strip. When we move through the first few frames, we can see that almost nothing happens until around frame 6, when this characters begin to lean and the main movement starts. Because we have a few stationary frames at the beginning, we can use those frames to give the simulation more time to settle. If your animation begins moving immediately, you can instead use only the first 1 or 2 frames. For this animation, I'll go to frame 2 and press Y to split the strip. When I zoom in, we can see that the animation has now been divided into 2 strips. I'll select the other character's strip and press Y at frame 2 to split that one as well. Now we have a small opening section for each animation. I'll move the remaining parts of both animations so that they begin around frame 10. Next, I'll select this small opening strip. Collapse the Active Strip tab and expand the Action Clip tab. Here, I'll change the playback scale value to 9. So we're basically taking the small amount of movement that originally happened between frames 1 and 2 and allowing it to happen between frames 1 and 9. I'll select the other character's opening strip and set its playback scale to 9 as well. Now I'll return to the Active Strip tab. I'll set the blend-in value to 5. This makes the character start from its default A pose before gradually transitioning into the animation. Let's do the same for the other character's opening strip. I'll select it and set its blend-in value to 5 as well. Alright, let's return to frame 1 and play the animation. Now we can see that the coat have enough time to simulate and settle around the characters before the main fight animation begins. Now we need to click the Match Frame button. I'll select one of these strips, maybe select the other one, and click Match Frame. Okay, now we can bake the animation. I'll select this strip, but we also need to make sure that the correct character rig is selected. With the wrong rig selected, you can see that the Bake button is grayed out. Once I select the rig that belongs to this strip, the Bake button becomes available again. I'll go ahead and click Bake, and then click OK. Alright, the animation has now been baked. I'll temporarily disable this NLA track and return to frame 1. We can see that the newly baked action is now controlling the character. This NLA track is no longer needed, so I'll right-click it and select Delete Track. I'll return to frame 1, select the other animation strip, and make sure the correct rig is selected. I'll click Bake and click OK. Let's disable this track to confirm that the baked action is controlling the character. So I'll right-click this track and delete it as well. Now both animations begin from the character's default poses before transitioning into the fight. Let's rename the actions using the Actions section so they're easier to identify. I'll remove the numbering here in the name. Then I'll rename it Default to Fists Fight B. Now I'll copy this part of the name, select the other character's rig, remove the .001 from its action name, paste the text I copied so we have Default to Fists Fight A. We now have both fight animations properly named. Let's return to frame 1. The next thing we need to do is position the characters so that their movements connect correctly. I'll play the animation and look for the frame where the character wearing the coat kicks the other character in the stomach. It should be somewhere around here. Let's move back a few frames. Okay, this is the point where the kick connects with her stomach. On this frame, I want the character's foot to be positioned exactly where the other character's stomach is. To make this easier, I'll split the viewport. This second viewport will be used to preview the animation. I'll press N to hide the side panel, then turn off the overlays and gizmos so we have a clean view. I'll keep this viewport at an angle where we can clearly see the contact between both characters. I'll use the other viewport to make the adjustments. I'll switch this viewport to top view. At this point, we can choose to position either this character or the other one. What I like to do is switch to wireframe mode and check which character is closer to the center along the x-axis. We can see that this character is already closer to the center, so I'll leave her where she is and position the other character instead. Let's return to solid view and select the rig we want to move. I'll open the Adjustments tab and click the Position button. Now, I can move the character until the foot is close to the correct position. You may notice that the shirt is strangely deformed while I move the character. This is happening because the simulation is still active. Once we play the animation, the shirt returns to its normal shape. However, if you don't want it interfering while positioning the characters, you can temporarily hide it. So, I'll select the shirt, and in the outliner, press the period key to locate it, and then hide it. Now, let's return to the frame where the kick connects. I think this is the correct frame. Let's frame that on this other viewport. I'll select the rig, click the Position button, lock the movement to the Y-axis, and move the character along that axis. I'll hold Shift to slow down the movement so we can position it more precisely. Somewhere around here should work. Now the foot is positioned where it needs to make contact. It's slightly passing into the body, but that is completely fine for a fast-moving fight animation. Let's bring the jacket back and return to frame 1. Now, let's play the animation and see how the positioning looks. I think this position should work. I'll minimize this second viewport so we have more room to work. The next thing we need to fix is the contact between the character's feet and the ground. I'll switch to side view, zoom in, and play the animation. If you watch this character's feet, you can see the ground level here. In some frames, the feet float above the ground, while in other frames, they sink below it. We'll use the IK controls to correct these floating and sinking problems. I'll pause the animation and expand the Kinematics tab. Now, let's enter pose mode. We'll start with this leg control. Let me toggle this IK-FK switch to have the panel refresh. Here, we have the left leg controls selected, so the Kinematics panel displays the controls for that leg. When I select the right leg, it switches to the right leg controls. We'll start with the left leg. Currently, the FK bones are controlling the animation. All the leg movement we're seeing is coming from those FK bones. What we need to do is make the IK controls follow the existing FK animation. I'll click IK to FK in the panel, set the frame range from the beginning to the end of the animation, and click OK. This process may take some time, so we'll wait for it to reach 100%. Alright, the left leg animation has now been transferred to the IK controls. We can switch back to FK and then return to IK. And when we play the animation, we can see that the IK controls are now animated just as the original FK movement. Let's do the same thing for the right leg. I'll select the right leg control, click IK to FK, and click OK. Again, we'll give it a moment to reach 100%. Alright, both legs have now been transferred to the IK controls. When we return to the beginning and play the animation, we can see that the IK controls are animated exactly like the original FK controls. Now, I want to work with the IK controls so we can fix the foot placement. Let's start with the left leg again. First, I'll open the armature data properties. Under viewport display, I'll enable in front so we can see the bones inside the character. I need these visible because we'll be working with both the foot control and this toe control. At the moment, the rig looks quite congested because we can also see all the simulation bones. Let's hide the bones we don't need. I'll return to object mode, select the shirt, and bring up the Simu Quick tab. Here, I'll click the eye icon button twice to hide its simulation bones. I'll do the same thing for the skirt and hide those bones. I'll select the hair and hide its simulation bones as well. That gives us a much cleaner rig to work with. Now, I'll return to pose mode and zoom in on the foot. As I mentioned, we'll be using this foot control together with the toe control. Let's return to the Kinematics tab. I'll collapse the SimuQuick tab, and here we have the Kinematics tab. I won't spend too much time explaining every button here. I'll use the tools as we work so you can see what each one does. The actual fight animation begins around frame 10. Frames 1 to 9 are only there to give the clothes enough time to settle around the characters. I'll go to frame 10 and set it as our starting frame. What we want to do is keep this foot firmly in contact with the ground for as long as it's supposed to remain planted. I'll expand this second viewport again so we can view the foot from another angle. Starting from frame 10, I'll move through the animation using the arrow keys and watch for the point where the foot begins to shift away from that position. We can see that it remains planted until around frame 21. So our first hold will run from frame 10 to frame 21. I want the foot to pivot around the toe, so I'll select the toe control. Before making any adjustment, I'll first return to the starting frame where I want to make the adjustment. Also, let's enable the transform gizmo. Set the orientation to normal, and turn on auto keying. Now, with the foot control selected, I can use the gizmo to position the foot properly on the ground. Somewhere around here should work. We can also correct the sideways rotation of the foot. Here, we can see that this direction is controlled by its Y rotation. So now, I'll click the reset button and disable location because we only want to adjust the rotation. The rotation is currently set to X and Y. So now I'll disable the X axes so that only the Y rotation remains enabled. With frame range disabled, the reset will only affect the current frame. But when I enable frame range, the adjustment will be applied to the specified frames. So with the frame range enabled, I will click OK. Now the Y rotation has been reset across those frames. Now I can position the foot more accurately. I think this placement already looks fine. Next, we need to hold the foot in place. I'll select the toe control and then click Hold. For this hold, I'll disable rotation because we only need to hold the location. The toe control itself doesn't contain the location data we are holding. It acts as the reference point to keep the foot positioned around the toe control. So now with the frame range set from 10 to 21 and click OK. Now let's move through the frames. From frame 10 to frame 21, the foot remains planted around the toe. Once we reach frame 22, it begins to move because the hold ends at frame 21. Let me quickly split this area and change the button window to the dope sheet. I like to have that visible. Sometimes, I'll delete one or two keyframes around the beginning or end of a hold to make the transition smoother. Now let's continue through the animation and find where the foot lands again. It comes down around frame 26, so we'll use that as the beginning of our next hold. From here, let's check how long the foot is supposed to remain planted. It stays down for a while, and then begins moving again around here. So let's insert that into the end frame field, frame 61. It's important to return to the starting frame before creating the hold. The tool uses the pose from the current frame as the pose it will maintain across the selected range. Since this hold begins at frame 26, I'll return to frame 26 before making any adjustments. I'll use Reset button again to correct only the Y rotation across the frames. Now I'll move the foot slightly lower so it sits properly on the ground. I'll select the toe bone because we still want the foot to pivot around the toe. Then I'll click Hold, enable only location, and with the required frame range set, I will click OK. When we move through the animation, the foot now remains planted in that position for the duration of the hold. Once the hold ends, it begins moving again. We can delete the final keyframe of the hold if we need to create a little more room for a smoother transition into the next movement. Now let's continue until the foot comes to rest again. It appears to settle around here, so I'll use this as the beginning of the next hold. Let's continue through the frames and check how long it remains in this position. There is still a small amount of movement here. If the movement were insignificant, we could simply hold the foot through it. In this case, however, the movement is noticeable, and it begins moving around this frame. I will set that as the end range. I'll return to the starting frame, use Reset to correct only the Y rotation, and move the foot slightly lower onto the ground. Then I'll select the toe control, click Hold, enable only location, and click OK. Okay, let's position the keyframes in the dope sheet. Now the foot remains planted until around frame 88, where it begins moving again. As before, we can remove the last keyframe of the hold if we need more space for a smooth transition. So now you understand how the hold and reset buttons work. I'll continue fixing the foot placement in a time lapse, and I'll pause whenever there's something new I need to explain. Alright, the foot is moving backwards here, and it looks like it lands again around frame 106. I'll use frame 106 as the starting frame. From here, the foot remains on the ground until the end of the animation. So I'll use this button to set the end range to the final frame of the animation. Before applying the hold, let's look closely at how the foot moves. I'll return to frame 106. When the foot first lands, it remains flat for a few frames. But around frame 112, it begins pivoting sideways from the heel. Normally, when we select the toe control and use hold button, the foot pivots around the toe. In this case, however, the movement is pivoting around the heel, so we need to handle it differently. I will hold the foot from frame 106 to about 111, just before the heel begins to pivot. I'll return to frame 106, switch to side view, and use reset to correct only the Y rotation. Then I'll select the toe control, click hold, enable only location, and click OK. Now the foot remains planted across those frames. From frame 112, the foot begins pivoting around the heel. Let's switch to side view. Then use frame 112 as the beginning of the next section and have the end field the last frame of the animation. I'll return to frame 112 and use reset again. This time, I'll reset both the X and Y rotations across the selected range. Now let me quickly demonstrate why we shouldn't use the toe control for this section. I'll select the toe control, click hold, enable only location, and click OK. Now when we move through the animation, you can see that the foot is now pivoting around the toe. That isn't the movement we want here because it doesn't match the original animation. So I'll press Ctrl Z to undo that hold. For this section, we need to use the foot control instead of the toe control. This allows the pivot to happen around the heel while the toe moves naturally with the rest of the foot. I'll return to frame 112. Let's switch to side view to confirm that the X and Y rotations are still reset. Now with the foot control selected, I'll click hold, disable rotation so that we're holding only the location, and click OK. Alright, now let's move through the frames again. This time, we can see that the foot pivots correctly around the heel instead of the toe, so we won't always use the toe control with the hold button. The control we choose depends on where we want the foot to pivot during that part of the movement. That completes the holds for the left foot. If we return to the beginning and play the animation while focusing on the left leg, we can see that there is now very little floating, sinking, or sliding on the left leg. And that brings us to the end of this tutorial. I'll continue fixing the ground contact for the right foot and repeat the same process for both feet on the other character. Then, in the next video, we'll start cleaning up the hand poses to create more convincing impacts and blocks. If you found this tutorial helpful and would like to see more Blender tutorials like this, please give the video a like. It lets us know the effort is worthwhile. And if you haven't already, subscribe so you don't miss the next one. Thanks for watching, and I'll see you in the next video.